Video of Automated, Advanced Healthcare Records Trends with HL7 2.x through 2.8 and version 3, plus C, User Segments, and HDFS. The shortage of expertise and complexity to delivery is resolved. We have automated the flow of HL7 messages from the originating raw feeds to parsing into JSON or XML, repairing into JSON, graphical presentation and hard copy reports and exporting into FHIR. Enhanced reporting and processing of our HL7 Healthcare Delivery. Custom graphical reporting and CSV extracts and exportation to FHIR or most any data files securely with AES Encryption. This video displays our parsed, repaired, encrypted JSON HL7 standard and C, user custom segments, messages. Select segments and fields for reports with filtering options to further refine your online reports and CSV extracts. Also drill into the segments and values including the occurrences. Here we are seeing a quick view at the existing segments and values for one specific company big data revealed. We allow storage of segments and their values for each separate company in which you take in HL7 message feeds, so quick in processing, added accuracy, establish reporting and the export to IR and other target locations for encrypted company level HL7 messages. Here we see 1, Z, segment. Z, segments are for user-defined segments. These segments are processed, parsed, reported on, migrated to FHIR. FHIRs are all HL7 standard segments. No, we are showing the creation of a new user-created, reusable, collaborative HL7 company with segments and columns within the user-defined segments. First, we are adding according to the input schema for this new company a couple of the standard HL7 segments and fields that most of you are used to seeing. Now we will add a user-defined special segment using the standard Z character at the front of the new name. This allows the happy open source parser to recognize this segment as a user-defined segment and process accordingly. These segments allow organizations to customize the data they need to pass along to other healthcare organizations, and the storage of these schema changes allow for big data revealed to report online and in hard copy this user-defined healthcare information. Here we are viewing a raw HL7 feed that happens to have a user-defined Z segment type. Though it is the only unencrypted data in our feeds, we can read unencrypted input feeds or encrypt the feed prior to processing of the HL7 messages. Now we set up to process the HL7 input messages by pointing on the company big data revealed to the HL7 source path and select the location to store the happy parse JSON results for big data revealed to continue its processing of repairing, encrypting and prepping the HL7 messages for users to select the segments and data they wish to report on from the graphical interface and hard copies. Now that the process has completed to parse the standard and user-defined Z segments into JSON, we can see that BDR has stored these results securely encrypted. Now the user selects the files in which the HL7 messages are stored in which the user desires to report on. Then the user will begin to select both the user-defined Z segments and values, then the standard HL7 segments and values the user also wants to report on. Now the user selects the files in which the HL7 messages are stored in which the user desires to report on. Then the user will begin to select both the user-defined Z segments and values, then the standard HL7 segments and values the user also wants to report on. Now the user selects to run the query and reporting process. Clicking on the view, we can see what segments and values we requested for our process. Now that the process is complete, we are viewing the results in a query and we see that the Z user segments are also present in our query results. If there are multiple paging, we can view any pages, and for large volumes of results we have server-side pagination to make viewing in seconds. The user can optionally click on the export icon and BDR will send a CSV file to the user's device for additional or later reviewing. Here we see the storage of the user-created query, for it can be recalled at a later time. As we see, though, the query results are stored securely with encryption as it is for all the BDR HL7 processing. Now we are viewing the storage of the happy parsed HL7 segments along with the user-defined Z segments. As we can see, all the data is securely encrypted, again as all staging of BDR where BDR has control is kept secure and encrypted. Here we see that BDR stores metadata for the lineage of the processes that are submitted and ran against the HL7 messages, as well as BDR has always stored metadata and lineage for processes that are run and access into the BDR application. In the real world of healthcare, the volume of HL7 messages can be vast, making it difficult to find what users are searching for and necessary for their delivery. BDR allows the query results to be searched by the values of the segments, including Z segments and values, along with all other field results reported on, for quicker and accurate viewing. HL7 transactions are encrypted and stored as a JSON file in a data lake file. We parse the HL7 into JSON, prepare the data, then make the data available for reporting. Process HL7 and soon FHIR November 1st, with the latest Spark 3 Java technology and happy within a BDR framework. BDR's technology delivers immediately as an AWS, AMI, as a virtual machine or installed in your own environment. HL7 and soon FHIR projects can be delivered in a fraction of your original project time and budget estimates with far superior accuracy. We can take HL7 data from data at rest or streaming IoT continual feeds. Reach us at 847-440-4439.